Okay, guys, so let's go ahead and take a look at the method of Lagrange multipliers. Specifically, we're trying to find the maximum value of x squared plus 2xy minus 7y squared. And it has to be subject to the constraint 4x plus 6y minus 62 equals 0. Okay, so the idea here is that the gradient of the function you're trying to maximize or minimize, which is gradient of f, and gradient of g, which is the constraint, must be proportionate to each other. So let's go ahead and find the gradients. So for x, this will be 2x, right? 2xy with respect to x, that'll be 2y, because 2 and y are now going to be numbers. And 7y squared will drop out because that's 0 with respect to x. And then for y, we will get 2x, right? The first term drops out, minus 14y. Okay, for g, that's very simple. Derivative of 4x is 4. The other terms just turn into 0. Similarly, for y will be 6. Okay, so let's go ahead and put that in here. And hopefully we got that correct. Let's just check it. Okay, so that part's good. All right, so how do we figure it out? How do we find this critical point? What we do is we set the gradients equal to, the first one equal to lambda times the second one. And so this lambda thing is called Lagrange multiplier. But what does this really mean? When two vectors are proportionate to each other, that means that the x component of the first one is going to be lambda times the second one, the x component, and same thing for the y components. They're also going to be proportionate. So what you can do is just divide the first equation by gx and the second equation by gy, and they should be equal to the same number lambda. Now, the only time you have to worry about this division by 0 if gx or gy can be zeros. But in this case, for me, they are both 4 and 6, so I don't really have to necessarily figure out what that lambda is. I just need to use the proportion to express y in terms of x. That's my idea. So let's go ahead and set them equal to each other and see if we can express one of the variables in terms of the other one. So here for solving the proportion, we're going to cross multiply, right? So like this times this. Okay, so let's go ahead and do that. So we go to 12x plus 12y equals 8x minus 4 times 14. So that's, hold on. I think I had it here. Let me just do it again just to make sure. Okay, I had 56y. Okay, so then what we do is we're going to subtract 8x from both sides and also subtract 12y from both sides and see what happens. So this is going to cancel. This is going to cancel. So 12 minus 8, that's 4. And on the other side, we've got negative 56 minus 12. So that's negative 68. Finally, we're going to divide both sides by 4. That's negative 17. I'm sorry, I'm missing a y here. Okay, there you go. So now I expressed x in terms of y. So the next step is that you have to remember that it has to satisfy the constraint. So the critical point has to satisfy the constraint. And you always need to use it at the end. Okay, so instead of x, I'm going to plug in negative 17y. And hopefully got a nice number here. Okay, so let's check that out. So 4 times negative 17, negative 68. Negative 68 plus 6. That's negative 62. Okay, so you got negative 62, y equals positive 62, right? And so I think what that means is that y is going to be negative 1. And then x, which we can get it from here by substituting negative 1. So I think that would be 17. So there's your critical point. But let's check that out to make sure we didn't mess up. Okay, so then what you do, that the rule says it has to be a max or a min. It has to appear there. Okay, so how do I find the maximum value? Well, I have to substitute it back into the original function. Okay, so let's see. So let me just open the Desmos over here on the side, and let's define f of xy to be, let's see what it was. It is x squared plus 2xy minus 7y squared. Okay, so what is it at 17 negative 1? So that's 248. That's going to be the maximum. But how do I know that it's really maximum and not minimum? What you can do is just take another point, not 17 negative 1, something else that would belong to this constraint, and plug it in and see what happens. Like, is it going to be larger than that? Then that's actually going to be a minimum. Or if it's going to be smaller, then it'll be a maximum. So let's see. So what we're saying is that any other point that belongs to the constraint, if we plug it into our original function, we're always going to get a smaller value. Okay, and you can, that's the result. That's what it says. But let's see what happens. So what can we pick? Like, which point can we pick that would belong to this constraint? So let's just, for example, pick x equals 1. Okay, so if x equals 1, what will happen? So let's just subtract 4. This is going to be 58 over 6. So it's going to be some fraction, 29 over 3 or something. But it belongs to the constraint. Okay, so that one is definitely smaller than 248. So pretty much we already know it's going to be a maximum. I mean, you can try any point, and because this result says it has to be one of them, either max or a min, now you just pick another point and see if it's less or more. And if it's less, then that's a maximum. If it's more, it's a minimum. So just for example, if I can pick also x equals 0 and 62 over 6 for y, and you can see that it's negative. But does it have to be negative? So how about if y is 0? And then x would be 62 over 4. No, it's going to be 240, 25, but it's still smaller than 248. So 248 is your maximum.